flowing in your fuselage. So that now electrolysis, yeah. So if you have this similar metal, it will react faster and it will corrode faster. If it's similar, then it's little slower, but it takes a little time for it to start corrosion. The idea is corrosion is the biggest, what do you call, is the most important issue on an aircraft. Corrosion weakens the structure. When it weakens, it is a safety issue, which means it can fail. The part, if you, like you've seen on metal, you might have seen, yes? You have rust on it. So when it flakes, yes? It flakes. And when you clean it, you see it has eaten into the metal. If you clean the metal, you will have pitting on it, yeah? Or where the metal has been eaten away by corrosion. So that means that if you have a skin which is 32 tau and there is corrosion on it, it will begin to pit. So it's not exactly 32 tau. It will be less than 32 tau. So it becomes weak. Yes. So it's a weak part of the structure. Okay? All right. So now these are lap joints, these are wings. And as I said, rigidity also, you get rigidity on any surface. If it's a long, you see the length of that. If you just put a plain aluminium, you would have flexibility. You understand? Yeah. So when you do these flutes like these, it gives you rigidity. You see, it's nice and firm. You see, okay? So that also gives you rigidity. Also, if you take an aluminium sheet and you bend it, that bend will make it rigid. That surface. If you can practice in your anywhere. You take a plain sheet of Mabati, and then you see how flexible it is. Then you put a bend on it, 90-degree bend, and you see it gets automatic rigidity. That you must do as a practical in your class. Okay, all right. So this is the flaps. That's the ailerons. Okay. You must understand what each control surface is. That now you're going into theory of flight, but we won't do that. When we come to it, I'll explain to you what it is. So right now I'm just explaining to you how it is made and where the lap joints are, yeah? Because we are on the thing about talking about scratches and dents and all that. So if we go back there, I'll show you the other sample that I showed you. See, according to the syllabus, it tells me what is a dent. Okay, a dent, aluminium, because if you hit something on an aluminium, it will dent. Yeah, once it dents, it remains in that place. It doesn't flex back. There is a certain amount of flexibility that the aluminium will be able to sustain. But a dent is when it has stretch. The material has stretch, and you cannot straighten it. It's not like a motor car or a steel where you can panel beat it, yeah, because it won't happen. It will never be flat and smooth, because smoother the surface, less drag on an aircraft. Yeah, that will come with your aerodynamics. Smoother it is. If you have a car which is very, very well polished, you can see the racing cars. They're very well polished and they are absolutely free of any airflow disturbance on the surface. That gives you that extra speed through the air. Yes. Okay. So dent. I explained to you. This is a dent. Yes. Okay, and it can be repaired. If you have a localized dent, there is a repair scheme in most of the manuals. The manufacturer will tell you exactly how much is allowable for you to repair or place a repair. If the damage or the dent is beyond a certain size and there is nothing in the manual which guides you, then what you have to do is you have to talk to the manufacturer, write to them and tell them this is what it is, and they will approve a scheme, or they will tell you to replace the entire panel. You can see the panels are pretty long. On the wing, the panels are some to 8 to 10 feet. On larger aircrafts, they can be 30, 40 feet long. Okay? Single panel.